Hey guys, Mr. Riz here. So I'm going to help you out with the 1.1, 1.3 review in calculus. So we're going to go over the problems, make sure we are all set and be ready for the quiz coming up after this. So first couple questions here, what we're going to do is use the table. So I have Desmos pulled up to the side here to help us estimate the limit as we approach a number. I realize that as x goes to x, obviously that one should be x goes towards 2. Let's make sure the other ones are all right. Yeah, okay. So what we want to do here, if we're going to use the table, we're going to type it into Desmos, the function. So I got x minus 2, and then I need to divide this all by x squared minus x minus 2. So we're going to go closer and closer to 2. So we can kind of click and drag the point here and get closer. So as I get closer here, I can see 2 is undefined. If I hover over it, it's undefined. Let's see if I go the other way. It's like 0.4, 0.35. Yeah, it's kind of, I don't know, my mouse is being 0.34. And if I go the other way, 0.32. So maybe let's look at the table. To get a table, we're going to click that little gear, click convert to table. I'm just going to type in the numbers 1.9, 1.99, 1.999. 2 gets undefined by 2.0. 1, 2. All right, so if you look here, if we follow the pattern of what's going on, we're getting closer and closer to 1/3, so 0.333. So I'm going to type in 1/3. That's an easier fraction than to try to guess the decimal. So 1/3, because we get like 0.3 repeating. In fact, like we can go through, pick an even closer point. Okay, so next question, same thing again. What's the limit as we go to sine x divided by x? Now we probably should put this in degrees or radians, but since we're going to 0 degrees is the same as 0 radians, so it really won't matter. Now if we look at this here, it gets closer. All right, it looks like we get really darn close to 1, just scrolling over it. But let's make a table to change this. So I have negative 0.1, and negative 0.01, negative 0.001, 0 is undefined. All right, so yep, we can see 0.9, 0.9999, 0.9999983. Yeah, so I would say that limit goes towards 1. We are getting closer and closer to 1. Okay. Now the next one here, we're going to use the same limit. So you know what I'm going to do? I'm just going to click this function here. I'm just going to rewrite the function. So we have the natural log of x plus 5 minus the natural log of 5. And this is all going to be divided by, can I do that? Yeah, I think I can. X. All right. What's nice is that table is already set up for me now. I can look here, 0.202, 0.2002000, 0.20002, and then here 0.19998. So it looks like we're getting closer and closer to 0.2. Oh. So 0.2 is 1/5 if you want to put it as a fraction as well. So all right, so now what we're going to do next is we're going to estimate the limit and then use a calculator if we can. And if it doesn't exist, we just write D and E. So, okay, can I plug 0 into this one here? So if I try to plug 0 into this function, zoom in a little closer here. If I plug 0 in, we'd get 0 on the denominator. So we have to use the, the calculator here to help us figure this out. I mean, you guys probably know the other technique here too, which we'll go over, but we'll use Desmos to help us out. This is a tool available for us. Let's see, shift. Oh no. All divided by x. Okay. So nice thing here, I already have a 0 plugged in. 0 works out great. You can see it gets closer and closer to -2. Now 2 would be a number I could just plug in. I'm going to be lazy. I'm going to use the table here, and 2 would go to 0. If I plug 2 in, we get what? 4 minus 4 over 2. So we get 0. So these problems here are seeing if we can plug it in. We plug it in. If we can't, we can't. All right. Let's look at this next one here. No, let's see. I could plug 1 in, right? I got 3x divided by x minus 2. I could plug 1 into the table here. Actually, we see 1 does go to -3. All right, what about 2? Well, 2, it says undefined. Well, let's get a point. 2.001. Oh, that's a huge number. Let me go to the left of 2. 1.999. That's a huge negative number. So if we notice here on 2, and especially if we look at the graph, as we get closer and closer to 2, coming from the left side, it goes down. The right side goes up. So we would say this does not exist. The limit is not going towards the same number on the left and the right side. Okay. Now the rest of this, we're going to use analytical work. So we're going to practice our skills because you guys will be taking your quiz on paper. And I'll make sure you guys are all set for that. So let me annotate this here. Oh, I also want to make sure I'm sharing the screen. Okay. So when we first do our analytical work, we want to see if we can just plug in the number. So if I'm taking the limit as we go to 4, can we use direct substitution? 3 times the absolute value of 4 minus 1. So this is 3 times the absolute value of 3. Absolute value of 3 is 3, so 3 times 3 is 9. So we plugged it in. Nothing crazy happened. It never went away. It worked out fine. Now this next problem, if I try to plug in 3, I get 9 squared minus 9 over 3 minus 3. So 0 over 0. Okay, so that does not work. We cannot divide by 0. So what we would need to do on these problems here, if we can't plug it in, if we can't use direct substitution, we got to find an equivalent equation. So I'm going to factor x squared minus 9 to x plus 3 times x minus 3. And then we still have over x minus 3. And when that happens, the x minus 3's cancel out. So really, an equivalent equation would be x plus 3. Now that is something we can plug or direct substitute 3 in for x. So what's 3 plus 3? That would be 6. We can always double check our answers using Desmos or a graphing calculator, but I want you guys to show your work on the test. It will be a paper test, a paper quiz, whatever you want to call it. So there we go there. So that one will be 6. Oh, yeah, let me type these answers in. What was this one? 9 and this one 6. I should double check that my answer key is set up right now as well. Okay, next problem. Let's go through it. So, okay, can I plug 5 in? No, that'd be 15 minus 15 on the bottom. So let's factor. The top can factor 2. What two numbers multiplied together give me negative 35? Add together to get 2. That'd be x plus 7 and x minus 5. Now on the bottom here, what I want to do is I want to get rid of like this 5. So can I factor out an x minus 5? And in order to do that, I would have to factor out a negative 3 to make that a negative 5 and then make that a positive x. So, okay, so it cancels out. Our equivalent equation is going to become an x plus 7 over negative 3. Okay, so that is going to be something we use our direct substitution for. Plug in our 5 for x. What's 5 plus 7 over negative 3? What's 12 over negative 3? That'd be negative 4. And we could have double checked that on Desmos. Okay. Ooh, fun one here. All right, find the limit analytically. Okay, so when we have radicals, we need to multiply the top and bottom by the conjugate. So radical x plus 5 plus radical 5 on the top and on the bottom. Okay, so that means the top equation, if I FOIL this out, radical x plus 5 times radical x plus 5 is an x plus 5. Now the middle terms, we'd have a positive, we'd have a negative mix of the two, they cancel each other out. So lastly, I have a negative radical 5 times a positive radical 5. That becomes just a negative 5. And the bottom is x times the conjugate. Okay. Well, we actually get a lot of things to cancel out next. 5's cancel out, and then the x's cancel out. So our equivalent solution would be 1 on the top, there's still 1 up there, and then over the conjugate. Okay, so that is going to be the function we're going to use direct substitution with. We're going to plug 0 in for our x. So we get 1 over radical 0 plus 5 plus radical 5. So we get 1 over radical 5 plus radical 5, which is 1 over 2 radical 5. Now, how do we make this a radical something divided by something? Well, okay, just go back into some old rules we have. Got to multiply by a radical 5 over radical 5 to get this 5 off the denominator. So we would get on the top radical 5, on the bottom we get 2 times 5. So we get radical 5 over 2 times 5 is 10. So it's radical 5 over 10. Ooh, that was a long one. That's the tough problem to do. Well, one worth most points. Okay. One last problem here. No, 2 more to go. Okay, this problem here, if we have the function or the limit of, as we go towards this number c of f is 3/5, and if we go to the same number of g, it's -1/4, what would be the limit if we do f of x minus 2 times g? So really this is just saying, look, 3/5 minus 2 times -1/4. Okay, well, this would be what, 3/5 plus 1/2. Alrighty, let's do some fractions. Fractions are fun. Let's get a common denominator of 10. So if I wanted this to be 10, I have to make this 6. If I want this to be 10, I have to make that a 5. Add them together, we have 11 over 10. So if you want to put a 1.1 because you're lazy, that's fine. If you want to feel fancy, 11 divided by 10. Oh, it actually only has a numerical value. So, all right, Canvas, we'll get down to your terms. We'll put 1.1 in here. Alrighty, last one. We're looking at the graph here. We're going to find the values. If the limit does not exist, we type D and E. Okay, so let's look at f of -4. So remember, if we have an f, that's asking us where is the dot at -4. So if we look at our chart here, -4, there is a solid dot at 1. So, okay, we'll type 1 in. Next, what's the limit as we go towards -4? So the limit is asking where's the graph approaching? Well, from the left side, it's approaching 1. From the right side, it's approaching -2. Those are not the same numbers. It's not going to the same spot. So we're going to say does not exist, D and E. All right, one more problem here. What's the limit as we go towards, or what's f of 1? So where's the dot at 1? The dot at 1 is right at 1. So we'd say it is 1. Now, where's the limit? What's the limit as we go towards 1? Well, coming from the left side, we're going up towards 3. From the right side, we're going up towards 3. So the limit matches both the left and right side. So we can say it's 3. All right, let's submit the quiz, see how well I did. Did my answer key work out all right? 8 out of 8, I think I did good. I think you guys are going to do good on your quiz coming up here. Hopefully increase your scores, and yeah, you guys do all right. All right, guys, have a great day. I will see you guys next time. Good luck on the quiz.